When we look at the night sky, we see countless stars shining brightly. But could a star ever transform into something else? A planet, perhaps? This might sound like a strange idea, but in astrophysics, the life cycles of celestial bodies are far more complex and fascinating than they first appear. In this video, we're going to explore whether a star can truly become a planet and uncover the incredible science behind stellar evolution and planetary formation. Let's dive in. Stars undergo a series of transformations throughout their lifetimes, determined primarily by their mass. A star is born from a cloud of gas and dust, primarily composed of hydrogen and helium. Gravity pulls this material together, and as the pressure and temperature increase, nuclear fusion begins. This fusion process allows a star to shine for millions or even billions of years, depending on its size. Massive stars follow a different path compared to smaller stars. High-mass stars end their lives in dramatic supernova explosions, sometimes leaving behind black holes or neutron stars. Lower-mass stars, like our Sun, expand into red giants before shedding their outer layers and becoming white dwarfs. But what if a star doesn't have enough mass to sustain long-term fusion? One such category is brown dwarfs. These are often referred to as failed stars because they form similarly to stars but lack the necessary mass, about 0.08 times the Sun's mass, to sustain hydrogen fusion. Over billions of years, brown dwarfs cool down, slowly resembling gas giant planets like Jupiter and Saturn. Their atmospheres contain elements like methane and ammonia, which are also found in giant planets. If a brown dwarf cools enough over time, it might eventually become indistinguishable from a massive planet. Another fascinating possibility is white dwarfs transitioning over trillions of years. A white dwarf is an extremely dense Earth-sized stellar remnant left behind after a sun-like star exhausts its fuel. These objects are initially incredibly hot, but cool down very slowly. After trillions of years, a white dwarf could theoretically reach temperatures so low that it no longer emits visible light, becoming what scientists call a black dwarf. At this point, it would resemble a massive rocky planet, though it would still have a fundamentally different internal composition from typical planets. To understand how a star might transition into a planet, we need to examine the key transformations that must occur. A planet is defined as a celestial object that does not sustain nuclear fusion, has a stable structure, and often possesses an atmosphere or surface features. For a star to become a planet-like body, several processes need to take place. Cooling and shrinking. Brown dwarfs, for example, gradually lose heat over billions of years. As they cool, their physical properties change, and they begin to resemble gas giants. Loss of mass. If a star loses a significant amount of mass due to stellar winds, tidal interactions with a companion star, or collisions, it might eventually become more planet-like. Chemical and atmospheric changes. As a stellar remnant ages, the composition of its outer layers might change, potentially forming a thin atmosphere or surface-like structure. One interesting theoretical case involves extremely old white dwarfs. If given enough time, possibly longer than the current age of the universe, a white dwarf may lose nearly all its residual heat and become a cold, dark remnant. Such an object could have characteristics similar to a large rocky planet, though it would lack geological activity and a traditional atmosphere. There are a few real-life examples where celestial objects have transitioned from stellar-like states into more planet-like bodies. One of the most famous is PSRJ 1719-1438b, sometimes referred to as the Diamond Planet. This planet orbits a pulsar and is thought to be the remains of a star that lost most of its mass. What remains is an extremely dense, carbon-rich core that has likely crystallized into a diamond-like structure. This transformation suggests that under extreme conditions, stars can indeed become planet-like objects. Another category of planet-like remnants includes Chthonian planets. These are gas giants that have lost their thick atmospheres due to intense stellar radiation, leaving behind rocky or metallic cores. This process provides insight into how planets can evolve dramatically over time, shifting from one classification to another under extreme conditions. Our Sun, like other Sun-like stars, follows a well-understood evolutionary pathway. In about 5 billion years, it will expand into a red giant, engulfing the inner planets of the solar system. Eventually, it will shed its outer layers, leaving behind a white dwarf. While this white dwarf will gradually cool, it will never truly become a planet. However, material from the Sun's outer layers may contribute to the formation of new planets elsewhere in the galaxy. The elements produced inside stars, including carbon, oxygen, and iron, are essential building blocks for planets and even life itself. In this way, stars don't directly become planets, but their remains help create new planetary systems. The idea of stars transforming into planets is a slow and rare process. While brown dwarfs may evolve to resemble gas giants and white dwarfs might cool to resemble solid bodies, these changes take billions or even trillions of years. If the universe lasts long enough, many of today's white dwarfs may one day appear as dark planet-like objects floating in space. This concept also challenges our understanding of the boundaries between stars and planets. Objects like brown dwarfs blur the line between these categories, demonstrating that the universe doesn't always fit neatly into human-defined classifications. Perhaps in the distant future, some of the celestial bodies we consider stars today will be seen as planets in an ever-evolving cosmos. So can a star turn into a planet? While not common, there are scenarios where stellar remnants can take on planet-like characteristics. Brown dwarfs, white dwarfs, and stripped-down remnants of stars provide fascinating examples of how celestial bodies can evolve in unexpected ways. The universe is constantly changing, and the transformation of stars into planet-like objects is just one of the many wonders of astrophysics. If you found this video intriguing, don't forget to like, subscribe, and hit the notification bell for more deep dives into the mysteries of the cosmos.